Hi everyone, this is the lesson number 2 of the unit 1, the problem. Gonna talk about heat integration, the goals of heat integration and the problem again. Gonna start with a definition. Some heating and cooling may be saved by heat integration. Heat integration is the technique of putting process hot streams in thermal contact with process cold streams across heat exchangers in order to primarily save energy cost. Then, no more than this, putting hot streams in contact with cold streams across heat exchangers to save costs, no more than that. But these techniques have changed the way we design plants nowadays, and a well-designed plant should be heat integrated even when no contacts are actually implemented, are not put in place in reality. Our goals, our objectives, will be a set of thermal contacts between streams that we normally call the heat exchanger network. You can see here the onion diagram. At the center is the core of the process, where the units separation reaction lie. It is surrounded by the heat exchanger network, with thermal contacts between the two, taking heat in and out of the core. And then the heat exchanger network is served and surrounded by the utilities layer, with thermal contact that feed heat into the network and take heat out of the network. These are the heating and cooling utilities layer. Then our goal will be to find the optimal heat exchanger network for a problem. When designing a process from grassroots completely new, or when retrofitting it, an existing process that we want to improve. These objectives include the thermal contact of the heat exchanger network and also the utilities, the right amount and type of heating and cooling utilities. You must note that optimal can take into account multiple criteria. You can think in the minimum heating and cooling, energy cost of heating and cooling, minimum emission carbon dioxide from utilities if you are burning some kind of fuel, or you can take into account the minimum number of contacts, the minimum number of heat exchangers, or even the good control and operation of the plant, the startup, the steady state operation, or the shutdown. For the problem then, there will be an optimal set of thermal contacts that we want to find. If the process takes few streams, the best set of contacts is easily found by eye, because the possibilities are not numerous, and selecting the heat integration topology, the network, is easy. But as the number of streams increases, the pairing possibilities grows exponentially, and selecting the right topology for heat integration is difficult. Then we need methods and techniques. And in the way of solving this problem, we will learn a lot about energy and energy flows in plants.